general science. We're going to start talking today about geology. And what we're going to talk about is rocks and the rock cycle and all of that awesome stuff. So this video might be a little long, but that's okay. We're going to learn a lot of stuff. So hope you're ready to learn. Let's get started. So to start off, what are rocks? Well, rocks are just a solid mineral material that form part of the surface of the earth. And generally, they are either exposed on the surface or underlay the soils or oceans, so they can be anywhere. Okay? Rocks are also often an aggregate of different minerals, so there are many different minerals combined into one rock. So now the question begs, what's a mineral? And a mineral is just a solid inorganic substance that occurs naturally. So table salt is a mineral, right? It's a solid and inorganic substance that makes it a mineral. And a mineral is basically just any compound that's not organic, which basically means anything that you're not going to find like in a living thing. And this means that they have well-defined whole number ratios and a crystalline structure, much like salt. There are 3 different types of rocks, and we're going to talk about each one. Okay, and those rock types are the igneous type, the sedimentary type, and the metamorphic type. And these are all based on how they are formed. So that's how we divide rocks up. It's based on how they are formed into the form they take as rocks. So the first type we've got here is an igneous rock. And igneous rocks are formed when magma solidifies. So that means they are made from a partial or full melting of crust. And igneous rocks can form with crystallization to form granular rocks or without to make a natural glass. And so you can see we've got plenty of different examples over here of different types of igneous rocks, and you can see they all look pretty cool. And igneous rocks can form above or below the ground based on where the cooling occurs. So if they cool underground, they'll be slightly different than if they cool above ground. The next type was sedimentary rocks, and sedimentary rocks are formed by the accumulation of minerals and organic deposits that are cemented together. And these processes can happen both in or out of water, but many examples show accumulation in water. So that's generally where these kind of things happen. Sedimentary rock covers almost 73% of the Earth's crust, but is only 8% of the crust volume. And sedimentary rock study is an important part of determining the geological timeline, because as you can see in this big picture here, these lines can be used to determine the age of the rock around it. Then the final type of rocks there are metamorphic minerals. And metamorphic rocks are created when rocks are changed through different processes. So as you can see, we've got all these different rocks here, and some of them have been changed from a different type of rock into this rock via some sort of natural process. And those processes usually involve temperature greater than 150 degrees Celsius or pressures higher than 100 megapascals, which is very high, so it'd be under the earth. Metamorphic rocks are often made deep underground or in some sort of tectonic process like a collision, and metamorphic rocks are often used in construction and art, so things like marble, slate, etc. are different types of metamorphic rocks. Now let's talk about how we get these rocks, and there's a cycle for this. You're going to find that in geology and environmental science, you're going to find a lot of cycles. So this cycle is called the rock cycle. And this is what it looks like overall. Okay? Rocks are formed in this cyclical process, and then they're decomposed and reborn over long periods of time. So as you can see, we start the process here in magma. That magma might crystallize and become igneous rock, or it might slowly uplift towards the surface and then erode, right? Transport, become sediment, get buried, it might metamorphosize, or whatever, right? It all goes in this circle. So let's go over each step. First, of course, right, igneous rocks are going to form, and they're going to be formed in volcanic eruptions. And as the magma or lava cools, right, these new rocks are formed. And as more rocks form, land builds up, creating more crust, mountains, and volcanoes. Over time, this rock is going to be weathered down and eroded, right? Wind, water, natural events, these are all going to break down rock. And the result of the weathering is new sediments that can be turned into a different type of rock, like sediment rock. And as rock erodes, the bits and pieces become sediments, and they will eventually be compacted and cemented. And then you get these nice, cool layered rocks here. And the cemented rock is a sedimentary rock, and these rocks will form in layers. And like I said, right, they can be used as a timeline, which is pretty fun. Here's where they get compacted. So as you can see, the cementation process is a long process that takes thousands and thousands of years, and each distinct layer of rock is from a different sediment deposit. So that's how we are able to keep track of the timeline using these sedimentary rocks. Now, eventually these rocks are going to be buried, right? And so over time, the new sedimentary rock may be buried deep under the crust, and based on the time, temperature, and process, those rocks might metamorphosize. And so you can get different types of rocks based on the pressure and the temperature that happens. And this can be instantaneous, or it can take millions of years. So it can take a long time, or it can be really quick. Then, of course, now once it's underneath, it might also start to melt. And if the rock is buried for too long, it might melt, become part of the mantle, and then the whole thing's going to start over. Now, at any point during this cycle, the rock can be pushed back up again to the surface. So sedimentary rocks and metamorphic rocks can be pushed up to the surface as well. It's not just igneous rocks that are pushed up to the surface of the earth. And there we go. Here's our cycle again, right? The magma and lava erupt, and we're back at stage 1. So here are some more rock examples, just so you get something to kind of look at, because geology is no fun unless you get to look at stuff. And here are some types of igneous rocks. They break down igneous rocks even more. There's extrusive, intrusive, and plutonic. Extrusive rocks have quicker cooling times, and they have invisible or microscopic grains, so they're going to be more smooth. Intrusive rocks, they cool over thousands of years, and their texture has smaller medium grains. And then plutonic rocks have millions of years of cooling time, and they have really large grains like granite or other things like that. Here's an example of an igneous rock, which is basalt. And basalt is just a fine-grained volcanic rock that's primarily composed of plagioclase, pyroxene, and olivine. And more than 90% of all volcanic rock on the Earth is a basalt. Okay? It's also the most common rock on Mars, and basalt magma is thought to have their origin in the Earth's upper mantle. Thus, the chemistry of basalt provides clues to the conditions deep inside the Earth. So we're kind of using this as the basis of how we understand what's in the deeper parts of the Earth. Granite is another igneous rock, and it's a coarse rock composed of quartz, feldspar, and plagioclase. And it forms from the magma with high silica content. And so it's commonly found in the continental crust, and granite often lacks an internal structure, which makes it hard and tough, hence why it is often used in construction. Another rock we have an example of here is obsidian, and as you can see, it's very smooth and shiny. And obsidian is a naturally occurring volcanic glass. Obsidian is produced when felsic lava cools rapidly, and the lava that produces obsidian is high in silica content, which makes it difficult to crystallize while rapidly cooling. It's hard and brittle, and it can fracture into sharp edges. This used to be used in Aztec swords, which is why they used it, because it's hard and brittle, so it'll fracture into people. Sedimentary rocks, as you can see, we've got lots of different types, right? We've got these nice little layered things, and here's kind of like a hodgepodge limestone sort of rock, which is pretty cool. Limestone is a carbonate sedimentary rock, and it's composed of calcite and aragonite. And they're just different forms of calcium carbonate, basically chalk. So about 10% of sedimentary rocks are limestones, and limestone is soluble in water and weak acidic solutions, so it can be eroded super easily. Sandstone is composed mainly of sand-sized silicate grains, and so sandstones make up another 20 to 25% of sedimentary rock, and it's often composed of quartz or feldspar. And they can come in a variety of different colors, like tan, brown, yellow, red, gray, pink, white, and black. So there's lots of different colors of sandstone. And quartz-bearing sandstone can be made into quartzite through metamorphosis. And then we have shale, which is a fine-grained clastic sedimentary rock. And that usually means it's composed of like mud or clay and these tiny fragments of other minerals. And so shale can commonly break along really thin lines, and it's one of the most common sedimentary rocks. And then here we've got metamorphic rocks. And these are some examples of the metamorphic rocks here. We got different pictures of them. The first example we'll talk about is marble, and marble is just metamorphosized and recrystallized carbonate minerals. And so marble is often used in sculpture and buildings, and pure white marble is created using silicate poor limestone. Gneiss is another metamorphic rock, and it's very common. It's created from igneous or sedimentary rocks. And gneiss shows a banded texture characterized by lighter and darker bands of color. So as you can see, they've got these little bands in them. Gneiss is created at a temperature of around 320 degrees Celsius, and relatively high pressure. And this is a very nice quote that pretty much every geology professor you'll ever meet will say. That's a nice gneiss. And then finally, quartzite is formed from quartz sandstone, and it's usually created under some tectonic pressure. And they can come in lots of different colors as well. And as you can see, I have all the different colors down here. And quartzite is very resistant to chemical weathering and often forms ridges and resistant hilltops. Thank you so much for coming along here on our first little dip into geology, and I can't wait to talk more with you about all sorts of other things that come along when you talk about geology and environmental science. We'll see you soon. Thanks for watching. Bye.